Alright, lesson 20. We are pretty well, get it? Pretty well done with new materials. You have the quadratic equation. Now we're just going to talk a little more about different terms here today. Rational, irrational. So rational numbers that come out nice, can be written as a fraction, can be written as a decimal if it stops or it repeats. Okay, irrational, there are no patterns, doesn't repeat, goes on forever, cannot be written as a fraction.
5 nines comes out repeating.
Square root of 5 nines? That's the square root of 5 nines.
What about the square root of 16?
Well, it's 4, that's why it's rational. Right?
What's so funny?
So all I want you to do is tell me if these are rational or irrational under here. We'll put a little R or a I. So 97.
Rational.
Yeah, it's a nice number, right? Caleb can no longer answer. Negative 8.2, somebody else. That is rational. That is a nice decimal. It stops. Square root of 5. Irrational. No repeating pattern there. Negative 3/7. That is rational. Any fraction is rational. There must be a pattern eventually.
Any fraction?
Any fraction. If it can be written as a fraction, it's rational.
That makes sense.
Square root of 100. Yeah, that's of course just 10. Square root of 9 over 4.
Irrational. I thought once we answered,
No, that's rational.
Yeah, so that is 3 over 2, right? Square root of 9 and 4 is 3 over 2. That's 1.5, 1.5. That is rational. So you can't always say, oh, it's got a square root. It's irrational. Negative square root of 18. Do you know the square root of 18 off the top of your head?
No.
No, so most likely that's because it is irrational.
So then if it's the square root of 18, would it be negative because that negative
Well,
is in front?
You see, if I think
Yeah.
about it,
So
square
it'd be
root
like
of
the
18 is
negative
4.2426.
Yes, you had that memorized. That's impressive. This negative just means your answer would be negative. If it'd be inside, it'd be impossible. All right. So it says graph each quadratic using graphing technology. Identify the zeros and say whether you think they might be rational or irrational. Explain your thinking. So get out Desmos. Type that first equation in there, x squared minus 8. And what are the zeros?
Negative 2.828 and 2.828.
Negative 2.82?
Mm-hmm.
Now those are approximate. Can we tell if those are rational or irrational? Not really. We cannot tell just by looking at our graph because you don't know if that stops at the last digit. You don't know if it repeats. So it's hard to tell just by looking at our graph. Okay? Second one, I'd like you to type that one in.
Is there a way in decimals that you can say, like, what's this as a fraction?
I'm sure there is. So, second one, what are the zeros?
4 and 6.
4 and 6. So that one is definitely
Rational.
rational. Next one.
Positive.
5.5.
5.586.
And?
8.414.
Okay, so we have the same issues we did with the first one. We cannot tell by looking at that.
Are you kidding?
And we don't know if those repeat. It'd be yes if we would say rational or irrational. Last one. Okay, so same issue. So looking at a graph doesn't really help us. It helped us on one when it was perfectly nice whole numbers. Question number 2 says find out exact. And then rational, irrational. Again, you could use the quadratic. Anytime you have a problem like this, we had one like this yesterday on the homework. It is nice to just add 8 and then take the square root to get the square to disappear. So I take the square root of both sides, and I can see my answers are positive and negative square root of 8. You would have got the same if you did quadratic formula, quadratic equation. But now you can easily see, is that rational or irrational? Irrational.
Wait, how? Oh, yeah.
Wait, I don't necessarily see the.
Because if it's not a square root like perfectly, then it's.
I mean, all I did is basically solve an equation like this. Get x by itself, right? Subtract 1, you got your answer. That's all I did there. If you can't see that, then use the quadratic equation. B. Okay, we already said this one was rational, so I don't think we need to do that one. That one comes out nice. C and D are the ones that are in question. So my first step could be to take the square root of both sides here, right? I am solving for x. I want to get the rid of the squared term. The opposite of squaring something is square root. So if I take the square root of both sides, I should get that. And again, I think that's easier than FOILing, moving the 2e over, setting it equal to 0, getting a, b, and c, plugging it into the quadratic equation, but that is an option for you. All I'm trying to do is solve for x here. So how do I get x by itself?
Plus 7.
I already took the square root. Now I'm here. I still don't have x by itself.
Plus or minus square root of 2 plus 7.
I need to add 7. So my two answers would be 7 plus the square root of 2 and 7 minus the square root of 2, which now we can tell again that our answer is going to be, those are irrational. And you could type those in, make sure you get those decimal ones that we saw in Desmos. Question number D, letter D I guess, D is not a number. If I'm going to follow the same pattern, I'm going to add 5 to both sides. I want to get that squared term by itself. And now the opposite of squaring something is? Square root. So square root gets rid of the squared. Square root of 5, I have no idea what it is, so I'm leaving it. One last step to get x by itself.
Times 4.
Times 4. The opposite of dividing by 4 is times 4. So it's 4 times the square root of 5 and 4 times negative square root of 5. Could write it as one answer.
Always write plus or minus?
4 times plus or minus the square root of 5. Which the whole point of that was, again, to see that it's irrational.
Couldn't you kind of tell by like the graph?
Again, you can't really tell by those numbers. It could repeat right after, because Desmos is only showing you so many digits. All right, it says here are some numbers that it wants you to consider. Can you tell which ones are rational and irrational?
Yeah.
Which ones?
Well, 2, 3, 1/3 because it repeats.
And it's written as a fraction.
Yeah.
This side is rational, this side is irrational. Okay, so it wants you to consider the following statements. You have to decide if it's always true, true sometimes, or never true. If it's always true, it means just that. It always has to be true. There are no exceptions. It just takes one to disclaim it. So the sum of two rational numbers is rational. That means if I pick any numbers over here and add them, I will get another rational number.
Always true.
What about fractions?
Yeah, but
What's 2 plus a third?
Well, like, what about two fractions?
Okay, 1/2 plus 1/2.
One.
1/2 plus 1/2. 1.
I put it in
Yeah, you will not find one that doesn't work. That is always true. Sum of irrational and irrational is always going to be irrational. And again, it shows you some examples you can try. So 2 plus square root of 2.
true.
0 plus square root of 3.
Square root of three.
Yes. Can you come up with one that doesn't work? No. Always true. Two irrationals added together is always irrational.
Sometimes.
Some true, some numbers.
Square root of 2 plus square root of 3, you can't even do anything with that. That would be irrational, so that makes it appear
I feel
true.
like there's
Yeah, I feel like there's.
How about if I add square root of 3 and negative square root of 3? And again, I'm just choosing numbers up
It'd
here.
be 0.
That'd be 0, which is rational. So that one has to be,
sometimes true.
yes, sometimes true. Okay, same question now with multiplying. Two rational numbers multiplied together, that means two things on the left side here will always be another rational number. 2 times 3, a third times 1. Or a third times 3, I mean. 3 times 0, 2 times 0.
Always true.
Always true. The product of irrational and irrational is always irrational.
Always.
So multiplying something on the left times something
No,
on the right.
sometimes true, because 0 would always just be 0.
Yeah, anything times 0 will always make it 0, which is rational. And if I take 2 times the square root of 2, I'm going to get 2 square roots of 2, which is still irrational. So that is sometimes true. How about if I multiply 2 irrationals together? Square root of 2 times square root of 3 would be square root of 6. That's irrational,
But square root of 3 times square root of 3 would be square root of 9, right?
which is 3.
So sometimes.
I could also multiply those together, and that would be
How
1.
does that work? Because you're multiplying the square root of 3, not.
Square root of 3
Don't
times
you
square root of 3 is
typically
square root of
have
9.
to solve the square root of 3.
You could.
And then multiply it.
Times itself, and you will get 9. Type in square root of 3 times square root of 3 and see what you get.
It's 3.
It's 2.279.
No, square root of 3 times square root of 3 is 3.
What? How do you, how does that?
Type in square root of 3 times square root of 3.
That's what I did.
3. You don't calculate.
Square root of 3.
Is
times square root of 3.
So then where'd you get 9?
3 times 3 is 9.
And the square root of 9 is 3.
But how are you getting 2 3s? 3 times 3.
3 times 3
Get one
is
up.
9. Square root of 2 times the square root of 3 is the square root of 6. Square root of 5 times the square root of 5 is the square root of 25, which is 5. You multiply the numbers and then you still got to take the square root. It does not disappear. So that one is sometimes true. Again, not all the time like this one right here. Okay, take a look at your homework. See if we need to adjust any of these. Question number 1, what's rational, what's irrational? Just an R and an I there is fine. Question number 2, which solutions are rational? So which ones would qualify as rational there? Question number 3, solve, and then make sure you answer rational or irrational. Four, I think you can handle. 5 is matching. I think you can handle that one. 6 is going to need an adjustment. Georgia, I need an equation.
Okay. The equation is, okay, I got it. X squared plus 9x plus 20. Equals 0.
Can factor it or use quadratic equation. There is your problem 6.
You're welcome, guys.
7 can handle. 8 is a review. We're actually going to touch on this. I think the last lesson of this unit, review again, vertex form. That was from unit 6. And 9 is a review from unit 4. So I don't think any issues there going forward. So 1 through 9 with that adjustment for 6 for tomorrow.
What